has to be in the alternative. And the null always has equal to. Awesome. Great job. Now we have to find the test statistic. So I have x1 equals 28 and 1 to 55, x2 38 and 2 301. So
I have a question.
yes.
For the A, for the C, is there any question will be to the C? Like, can you show how the H1 with the P1 equal to 0? The B, I'm sorry, the B.
So
the
you
answer B.
yes. So this is the difference of two populations proportions. I cannot have just one. So this would work when we tested one population. See, this one does not have population 2, P2. P2 is missing.
So it's already wrong, right?
Yes, because we are testing the difference between two populations. This is correct only when we discuss only one population. But here we are talking about samples coming from one population with x1 28 and 1 to 55, and from a different population, and this second population is missing here.
Thank you.
Better, V?
Yes.
Okay. So then I'll go back to stats and tests, same thing, two population proportions, Z test, so that's 6. And x1 is 28 and 1 to 55. x2 38 and n2 301. And this time we want not equal to. And you know me, I like to draw. So I can see the shaded. Wow! Look at the p-value. I like the way it pops up with the shade. So a z statistic, or z0, if that's what you want to use, it's fine. Negative 0.5973, and the p-value is 0.5503. So back to the problem. Round to 2 decimal places, negative 0.60. P-value, point round to 3 decimal places. So now what do we conclude? Alpha was 0.01 in this problem. At alpha significance level 0.01. And we reject or fail to reject the null hypothesis.
You fail to reject it.
Of course. I'm writing it down, fail to reject the null hypothesis. Okay. So A and D are completely out. Do not reject or fail to reject the null hypothesis because there is not sufficient evidence to conclude that P1 does not equal P2. Do not reject because there is sufficient evidence. Yeah. So we cannot reject the null hypothesis. P-value is huge. Data coming from this particular sample really says that the two are equal. There is not sufficient evidence to conclude that they are not. We fail to reject the null hypothesis. Good. So now let's see if we want to come back to something else. You want to continue with what we're doing? You want to select anything you want.
Can we continue?
Which one? I couldn't hear you. Can you say it one more time?
I just asked if we can continue.
Okay. So you want to continue with what we have here?
Yes.
Very good. So let's continue. So every time we start a problem, I'm hoping that you understand and you get into the habit of writing down the information. So alpha is given to us as 0.01, and they want the same thing. They are independent samples from a large population using simple random sampling, so all conditions are fulfilled. So we want to test whether P1 is greater than P2. If the population 1 has a higher proportion than population 2 of whatever. And I have x1 equals 122, and 1, 242, x2, 136, and 2, 309. So which null and alternative are we going to use?
Probably use D.
D as in dog. The null has to have equal to, and the alternative, which now is H1, I'm sorry, is P1 greater than P2. Exactly. Nothing else matters here. Good. Let's determine the test statistic. Let's try independently and tell me what you get as the test statistic. One minute. That's all we need for these problems. We just have to be careful and read them, you know, carefully and clearly. Let me know when you have a Z statistic. With x1 on 122, n1 to 42, 136, and 309.
I have it.
Sorry, go ahead.
No. I want more than one. I want to write several. I'm ready. Tell me what you obtained.
Okay, so for Z, I have 1.4942. Do you need more or just for this one?
And the p-value?
And the p-value is 0.06755. 0.06755.
Good.
I got the same thing.
Of course. Me too. Here it is. I just did it when you did it. Two proportion Z test. Don't you like that area that pops up? So let me do this for everyone. I like the graph part. So in stats, we go to tests and then 6. And we enter 122. And then, what do I have next? 242. And then 136. And then 309. And we want the greater than. And I like the graph to draw. Okay, let's see what I did, because that's not what we expect. So that's 6. It did not take my selection here. Please enter. Okay. Good. Perfect. That's exactly it. 1.4942, and the p-value is 0.0676. So we wrote those down. And now let's draw a conclusion. Back to the problem. So 2 decimal places, 1.49. p-value 3 decimal places, 0.068 is 0.0676. So that's, they want 3 decimal places. And now we want to draw a conclusion. So what is our conclusion? Do we reject or fail to reject? Which one is bigger, p-value or alpha?
P-value.
Yes, p-value is bigger. I'm going to write it here, p-value larger than alpha. What do we always do when the p-value is larger than alpha?
Fail to reject.
Fail to reject. So we're going to look at the first 3. The last one makes no sense. So we do not reject the null hypothesis. This is the null hypothesis. We do not reject it because there is not sufficient evidence to conclude that P1 is greater than P2. Correct. So the other ones have the wrong symbol. And the last one says reject. So okay, so let's discuss the next one. Who would like to start it? Okay, I'll start it. In a randomized, nice, double-blind clinical trial, nice, or clinical trials of a new vaccine, look at that. Monkeys were randomly divided into 2 groups. Okay. Subjects in group 1 received a new vaccine, while subjects in group 2 received a controlled or control vaccine. So subjects 1 get the new, subjects 2 are the control. After the second dose, 127 of 743 subjects in the experimental group. So X1, I write it down, 127, N1, 743. Experienced drowsiness as a side effect. Okay. After the second dose, okay, X2, 84, N2, 624. Of the subjects in the control group, experienced drowsiness as a side effect. Okay. Does the evidence suggest that a higher proportion of subjects in group 1, higher proportion of subjects in group 1, keywords, higher proportion of subjects in group 1 experience drowsiness as a side effect than subjects in group 2 at alpha 0.01 level of significance. Verify the model requirements. Select all that apply. So remember, randomized, proportions, and the sample size versus population. So if the samples are dependent, we cannot conduct the test, right? So we have to be very careful. So it says they were double-blind, randomized. So if they're double-blind and randomized, they have to be independent. Verify the model requirements, select all that apply. So they cannot be dependent. The sample size is more than 5%, that will be a big problem. The sample size cannot be. The sample size must be less than 5% of the population size for each sample. The data come from a population that is normally distributed. We do not need that. We do not need that. The data come from a population that is normally distributed. If the other conditions, if the independence, and if we have to check this has to work. If this doesn't work, we can proceed. But we have to check it. We cannot just check here and say, oh, I think it's okay. No, I have to determine this and make sure that they are more than 10. Okay? Independent, this has to happen, and the sample size is less than 5% of the population size for each sample. So let's determine now and calculate N1 P1 hat 1 minus P1 hat and N2 P2 hat 1 minus P2 hat. So N1, 743 multiplied by P1 hat. I like to put in parentheses 127 divided by 743. And again, now I need parentheses, 1 minus this number, 127 divided by 743. This number, when I click enter, if this number is not more than 10, then we cannot proceed. Excellent. Okay. The other one is n is 624 multiplied by 84 divided by 624. And then again multiply by 1 minus that number of 84 divided by 624. When I click enter, if this number is not more than 10, I cannot proceed. So all conditions are fulfilled. Samples are independent, randomized, etc., etc. Determine the null or an alternative hypothesis. So again, let's go back to the keywords here. Higher proportion of subjects in group 1. So what do we select for the null hypothesis?
That it equals.
Of course. And what do we select for the alternative?
That it's greater than.
Exactly. That's it. Find the test statistic. So six. Okay, x1, 127. And my keyboard is okay, so n1, 743. x2, 84. n2, 624. And we want greater than P1, so that's all okay, and we want to draw. So we got the test statistic 1.851 and the p-value 0.0321. Back to the problem. So the test statistic, 2 decimal places, 1.85. And the p-value, 3 decimal places, 0.032. Okay, so now let's draw a conclusion. Is the p-value greater or smaller than alpha?
Greater than.
It is greater. So it is greater than alpha. Do we reject or fail to reject the null hypothesis?
Fail to reject.
Fail to reject. Very good. Awesome. I'm just writing it down. Fail to reject the null hypothesis. So if the population proportions are equal, one would expect a sample difference proportion. This is the interpretation of the p-value, so we have to be careful here. So if the population proportions, if they are equal, which means if the null hypothesis is not rejected, that is true, if they are equal, one would expect a sample difference proportion greater than, but it could be equal to. So they only said greater than, but it could also be equal to. Greater than the absolute value of, smaller, so greater than the one observed in about we multiply this number by 1,000. in about 32 of 1,000 repetitions of this experiment. So let me explain this again. So maybe I should just stop sharing for 1 second and just explain here with the graph. So the p-value, so the test statistic, so this is 0, test statistic is somewhere here, 1.851. That's a t-stat. So this is the p-value, all this area, percentage, probability, that's what it is. So this is 0.0321. So if the null hypothesis is true, obtaining a value greater than this is this probability. They are giving us a number of 1,000 subjects. So then when I multiply 1,000 by this probability, so times 0.0321, I get, well, we didn't use the 1 because they only wanted 3 decimal digits. We get 32 subjects in 1,000 would have drowsiness after taking the medication. Okay, so this is the p-value. We multiply it by 1,000 and say if the null hypothesis is true, from any 1,000 subjects taking this medication, about 32 of them will experience drowsiness. But it should have, the explanation should say greater than or equal to, not just greater than. So back to the problem. If the population proportions are equal, in other words, this is true, they are equal, one would expect a sample difference proportion greater than the one observed in about p-value times 1,000, because it gave us 1,000. Otherwise, I wouldn't have known. They have to give us a number to put this, calculate this 32. Okay? Do you need me to explain this again? Oh, we didn't finish, so there is one other question. State the conclusion. Any questions on this?